Hello everyone, very good evening. Kindly confirm if audio video is clear. Very good evening everyone. Please confirm if audio video is clear so that we can continue. Just check audio video. Okay, everything is clear. Chalo, let's start the session. So, this is the 8th lecture of set theory and algebra. In the last class, what did we discuss? So, we have already covered the concept of sets and relation in the previous classes. So, what is a set? What is a relation? What do I mean by different types of relation? Reflexive, irreflexive, symmetric, anti-symmetric, asymmetric, transitive, equivalence relation, partial order relation, post-set, lattice, different types of lattice. We have already covered all those things related to sets and relation. Today we are going to introduce the concept of functions. So please try to understand. It will take 2 lectures. So the idea is that we in the today's session we will understand the basic definitions of functions and different types of functions, and tomorrow we'll try to understand the type of questions which can be asked in the GATE exam. That is, how many onto functions are possible from a set A to set B, how many one functions are possible from set A to set B, how many bijective functions are possible from set A to set B, and how do we calculate the inverse of a given function. So these are some type of questions that can be asked in the GATE exam, and that we will cover in the tomorrow's session. But to understand the lecture which we are going to have tomorrow, we need the basic definition of the function, and that's what I'm going to cover in the today's session. So the very first thing is, what do I mean by a function? So we already know the concept of relation. So why it is a part of a set theory and algebra? Because the definition of function is basically related to the definition of a relation. So function is a relation which satisfy certain conditions. What are those conditions? We will discuss them. So first of all, a relation from set A to set B. I can say one thing. What? Every function is a relation. Every function is a relation. But every relation need not be a function. So what type of relations will eventually become a function? Namaste, Yashoji. So a relation from set A to set B is called a function. When do we call it a function? It's called a function if each element of set A, so this is the first set, if each element of set A is mapped with exactly one element, with exactly one element of set B. So every element of set A will map with exactly one element of set B for a relation to become a function. Okay. Now, if we define a function from set A to set B, if we define a function from set A to set B, then this set A will be called the domain of the function. Please try to understand. Function must be defined. Function must be defined for every element for every element of the domain. There should not be any element in the domain for which the function is not defined. So please try to understand. If I simply give you an example, that fx is nothing but x upon 1 minus x, x upon 1 minus x. So please try to understand. If I look at this function fx, then this function will not be defined at x equals to 1, because if you put x equals to 1, it will become 1 upon 1 minus 1, that is 0, 1 minus 1 upon 0, which is not defined. So what will be the domain of this function? What will be the domain of this function? So this function can take any real number. You can pass any real number to this particular function and it will produce an output. But if you pass 1 as an input to this function, then this function will not be defined. Therefore, domain will be nothing but set of all real numbers except the element 1. This is the set difference. So, from the set of all real numbers, subtract 1 and you will get the domain of this particular function. Yeah. So, this is the basic definition, that the elements or the set of elements for which the function is defined will be called a domain. So if you are defining a function from set A to set B, then A will be called the domain of the function and set B will be called codomain of the function. How do we denote a function from A to B? So if function f is defined from A to B, then it will be denoted like this. So if I define something like this, if somebody just write this, that this is a function, then it means it is a function. The domain of the function will be x and codomain of the function will be y. Okay. Now, anyway, so let's get to the definition and let's try to understand what actually is a function and what is not a function. So let's assume that this is your set A, this is your set B. Think in terms of a relation. Let's assume if we have elements A, B, C, etc. In set B, we have some elements 1, 4. Now, if A relates with 2, B relates with 1, B also relates with 3, and C relates with 4. Is it a function? No, sir, it is not a function. Why? So please try to understand. It is a relation. It is a relation from A to B. It is a relation from A to B, but not a function. From A to B. Why? Not a function from A to B. The simple reason is that every element should have exactly one image. Every element of the domain should have exactly one image in the codomain, but for B, there are two values. So, element B of the domain maps with two elements of the codomain. Therefore, it is not a function. Therefore, it is not a function. Why? Why? Because of two images of. Okay. Similarly, if I define another set, let's assume this is a set A, B, this is your set B. Elements 1, 2. Now, is it a relation? Please tell me. Is it a relation? Yes, sir. It is a relation that A relates with 3 and C relates with 1. It is a relation, but not a function. Why? Why is it not a function? Because no image for element B. Because no image of element B. So these are not the functions. So we are discussing functions. So let us define some functions first. But to understand one simple concept, that every element should have exactly one image. So some elements are having more than one image, therefore it cannot be a function. Some elements are having no image, therefore it is not a function. Every element should have exactly one image. We can say 1 to 1, sir. What 1 to 1? No, it's not. Yash, don't get confused with the definition of 1 to 1. First of all, something should be a function. Then only we'll talk about 1, 1, onto, etc. These two are not functions. These two are not functions. Forget about 1, 1. Forget about onto. They are not even functions. Okay. So, because I mean, simple definition is that your function must be defined for every element of the domain, and here there is no definition for element B, therefore it is not a function. And there should be a unique definition for every element. So B has two definitions, therefore it will not be a function. Don't get confused. Okay. We'll talk about one onto all as well, but hold for some time. I just say that this is A1. Now, is it a function? Is it a function? Sir, the simple definition is every element has exactly one image, so it is a function. From A. Next example. A. What if there are some extra elements in set B? What do I mean by extra elements? Let's say you have one. Now my question is it possible that multiple elements of the domain maps with the element? Is it a function? Fast. Is it a function? So you may say that sir, two elements of domain are having same image in B, but there is no problem with that. What is the definition? It simply says that every element of domain should have exactly one image. That is, every element of domain should map with exactly one element. Sir, A maps with exactly one element. B maps with exactly one element. C maps with exactly one element. So every element of the domain is mapping with exactly one element of the domain. So it's perfectly fine. It is also a function. But it is a function from A to B. Is it a function from B to A? No, sir, it is not a function from B to A, because if we see from B to A, one is having two images in set A. From B to A, B will become the domain. From B to A, B will become a domain, and this element will have two images in the codomain. Therefore, from B to A, it is not a function, but from A to B, it is a function, because every element of set A is having exactly one image in set B. Now, two different elements may have same image. Now you can think of one function, Yash. This is a B to A, not a function. So there is a function from A to B as well as a function from B to A. There is a function from A to B as well as a function from B to A. So this is two-way. Anyway, what if there are less number of elements at A? There are only two elements. My question, is it also a function? Is it also a function? Yes, sir, it is also a function, because every element is having exactly one image. So it is a function from A to B. So simple concept that you don't need to think too much. The simple concept is a relation will be a function from A to B if every element of set A is mapped with exactly one element of set B. A will be called domain, B will be called codomain. Now look at this particular example. So what is codomain? Talk about that. So here, domain is what? The domain is the set of all elements of set A. So domain is nothing but A, B, C. What is codomain of this function? The codomain is 1, 2, 3. Set B 1, 2, 3. Wait a minute. This is important to understand the concept of range. So here, what is the domain? Is EC. What is codomain? The codomain is the elements of set B. These are 1, 2. Now, if I talk about one special term which is known as range of the function, then what do we mean by range of the function? So, codomain is a set B. Sorry, codomain is the elements of set B, set of elements of set B. But what is the range of a function? So, the set of all elements of the codomain, set of all elements of the codomain which are mapped by at least one element of the domain, which are mapped by at least, they must be mapped by at least one element of the domain. So if we look at the definition, set of all elements in codomain, set of all elements in codomain which are mapped by at least one element of codomain, which are mapped by at least one element of domain, is called a range of the function. Okay, so here if we take the same example, what will be the range of the function? What will be range of the function? So range of the function will be a set of elements of codomain. It will be a set of elements of codomain which are mapped by at least one element. So one is mapped by at least one element of the codomain. One is mapped by at least one element of the domain. Two is not mapped by any element of the domain. Therefore, two will not become the part of the range. Two will not become the part of the range. Three is also mapped by at least one element. So this is the range of this function. Now, if we talk about this function, what is the range of the function? So, all the elements of the codomain are mapped by at least one element of the domain. Therefore, the range is actually 1, 2. Now, the idea is, sir, what do we know? So, range will eventually be the set of elements from the codomain. Range will eventually be the set of elements from the codomain. So, what can we say? We can say that range will always be subset of codomain. So it may be equal to codomain, but there cannot be any element in the range which is not in the codomain of the function. There cannot be any element in the range which is not in the codomain of the function. So this is the basic definition. I hope you have understood that what is a function. Every element should have exactly one element. Now, if we talk about codomain, it may be the case that all the elements of codomain are mapped by some elements of the domain. It may be the case that some of the elements of codomain are not mapped by any element of the domain. So, if every element of codomain is mapped by at least one element of the domain, then it will become an onto function. If there is at least one element in the codomain which is not mapped by any element of the domain, then it will not be an onto function. So we'll talk about one and onto function in the upcoming lecture, but for time being, I've just given you the introduction. Okay. Now, if somebody asks you that given the cardinality of set A and set B, let's assume set A is of size m and set B is of size n. If I ask you the total number of functions possible from set A to set B, then what will be the answer? If I ask you the total number of functions possible from set A to set B, then what will be the answer? Okay, let's look at this. So this is your set A. It contains m elements. Assume that this is the element A1, A2, A3 up to AM. This is your codomain B that contains n elements. B1, so how many functions are possible from A to B? Now, simple concept is, sir, this first element of set code, this first element of domain should map with exactly one element of codomain. So this first element can map with in how many ways? Sir, the first element A1 can map with any one of these n elements in n ways. The first element can map in n ways. Yes, sir. Now, if we look at the second element, in how many ways this second element of the domain can map with exactly one element of the codomain? Now, the question is that if element A1, look at this carefully, if element A1 is mapped with this element B1 of set B, then is it possible for this element A2 to map with the same element of codomain? Yes, sir, it's obviously possible. Let's go back to the definition. Two different elements of the codomain may map to the two different elements of the domain. Two different elements of the domain may map to the same element of the codomain. So it is absolutely possible in a random function to map two or more elements of the codomain with the same elements of the codomain. Two or more elements of the domain it is absolutely possible to map two or more elements of domain with same element of codomain. Okay, so for this second element also we will have n ways. For this third element, how many ways are there? Again, this third element also can map with any one of those n elements, so n ways, and so on. This last element also can map with any one of those n elements, so n ways. So how many total functions are possible from A to B? The number of functions possible from A to B. First element can map with n ways, and second element can also map with n ways, and third element can also map with n ways, and up to the last element can also map with n. Sir, how many times? So this is m times. So each one of those m elements, each one of those m elements of domain can map with n ways. Therefore, n into n, how many times? M times. It will become n raised to the power m. Yes, please cross check. You said m raised to the power n, whereas the number of functions will be n raised to the power m. Now, not to get confused with m and n, not to get confused with m and n, I would just say that the number of functions from A to B from A to B will be equals to cardinality of set B raised to the power cardinality of set A. Basically, what is B? B is the codomain. So, will be nothing but size of codomain because in terms of m and n it may be confusing. In terms of m and n it may be confusing, but if you remember that the formula for the number of functions from A to B will be size of codomain raised to the power size of domain. So you'll always know what is domain and what is codomain. Not get confused with m and n. Size of codomain raised to the power size of domain. Clear? These are the total number of functions possible from any random set A to another set. Now, if we define a function from set A to set A itself, is it possible to define a function from a set A to the same set A? Yes, it is possible to define a function from set A to set A, and it will be called a function on set A, just like a relation. If we define a relation from set A to set A, then it is called a relation on set A. Similarly, if we define a function from set A to set a function from set A to set A, that is f from A to A, is called a function on set A, is called a function on set A. It's trivial thing to ask that if mod A equals to n, then the number of functions possible from A to A will be n raised power n, because the size of domain is exactly same as size of codomain. Clear? So size of codomain raised power size of domain will be nothing but n raised power n. Nothing new. Okay. Anyway, so now we know about the number of functions. So today we will only talk about total number of functions possible from set A to set B. Those more important definitions related to function, that is one function, onto function, bijective function. So how many one functions are possible from A to B? When exactly the one functions are possible from A to B? How many onto functions are possible from A to B? When exactly the onto functions are possible from A to B? How many bijective functions are possible from A to B? When exactly the bijective functions are possible from A to B? That all we'll discuss in the tomorrow's session. We cannot include everything in a single session. But let's talk about something which is related to the types of function. The very first category is identical function. When do we say that two functions are equal or identical? So they may write equal. If it is equal, it will be more clear. But if they are writing identical, you must understand that identical and equal are the same thing. That two functions f and g are said to be identical or equal when? What is the necessary condition for two functions to be called identical? Sir, the idea is two functions f and g are said to be identical when both the functions have equal domain. That means the domain of f should be exactly same as domain of g. They should have, both the functions have equal range. That is, range of the function should be exactly same, function f should be exactly same as range of function g, and more importantly, the value of fx should be equals to gx for all the elements belonging to domain. The value of fx should be equals to value of gx for all the elements belonging to domain. Now, if I ask you a question, let fx is equals to log of x square and gx equals to 2 times log of x. Statement 1. Fx and gx are identical. Fx and gx are not identical. Which one is correct? Which one is correct? S1 or S2? Fast. Which statement is correct? S1 or S2? I just want to know whether you have understood the concept or not. Identical function, by definition, it is damn easy. By definition, it is very easy that two functions f and g will be called identical if they have equal domain, if they have equal range, and the value of function f and g are same for all the elements in the domain. So that's what 𝐂𝐚𝐭𝐜𝐡. So you are saying S1 is correct. You are saying S1 is correct. Now the idea is, most of you know that log of x square is exactly same as 2 times log of x. Log of x square, you can bring this to front of log. So log of x square is 2 times log x. Come on guys, they are not identical. And that's the problem. If you do not follow the definition, then it's very much possible that you will pick the wrong answer. You'll select the wrong answer. So please try to understand. Do you know about log function? Do you know about log function? So if I just try to give you intuition behind the function, so this is basically graph for y equals to x. Yes or no? Graph for y equals to x. Your x-axis. I simply draw your x-axis, y-axis. This is graph for y equals to x square. So you should have this general understanding the graph for the different functions. Is by your x-axis, y-axis. This is nothing but the function. This is the graph for function y equals to x cube. Similarly, this is the graph for function e raised power x. For x, and at e equals to 0, this value will, x equals to 0, this value will come out as 1. X equals to 0, value come out as 1. Now this graph for function log x. This is the graph for function log x. Okay, if you understand this, then please at log, what is the value of log 1? Sir, the value of log will be 0 at input 1. So this at x equals to 1, the value of log will be 0. Now please try to look at this question carefully. Sir, the log is defined only for positive real numbers. What is the domain of the log? Sir, function log is defined. Log is not defined at 0. Log is not defined at 0. But log is defined on all positive real numbers. You cannot pass negative real numbers. You cannot pass negative real numbers to the function, to the log function. here, what will be the domain of fx? What is the domain of fx? Please tell me. What is the domain of fx? So the domain of fx is that you can pass any real number to this function log x square except x equals to 0, because if you pass negative real numbers, then also this square will make it positive. If you pass a negative real number to this function, then a square will make it positive. So log is defined for a positive real number. So the domain of function fx will be nothing but all real numbers except 0. Domain of function fx will be all real numbers except 0. And what will be the domain of in function gx? In function gx, this value has to be greater than 0. This value of x has to be greater than 0. You cannot pass a negative real number to this function gx. If you pass a negative real number to this function gx, then 2 times log of a negative number will not be defined. Therefore, the domain of function gx will be all positive real numbers. Will be all positive real numbers. So domain is not same. Domain is not same. Domain of fx is not equals to domain of gx. Therefore, cannot be identical. The very first condition for two functions to be identical is that their domain must be same. Clear, Kanchi? Kanchi ji, that statement S2 will be the correct answer, that fx and gx are not identical because their domain is not same. Simple concept that for two functions to be identical, they must have equal domain, they must have equal range. And if these two conditions are satisfied, then the value of function fx should be equals to value of function gx for all x belonging to domain. Yeah. Okay. Let's move to the next concept. We are done. The identical function. First slide. Anyway, now if I simply ask you another question. Cos 2x. Identical or not? Fx and gx are identical or not? Fast. If you have understood the concept, now you should be able to answer this. S1 is true or S2 is true? S1 is it true or S2 is it true? So, sir, for function fx, what will be the domain? Sir, you can pass any real number, there is no problem. You can pass any real number, there is no problem. For gx, what will be domain? Sir, if you want to calculate the domain of function gx, you must ensure that within the under root, you cannot pass any negative value. So, domain, so for function gx, for function gx, x square has to be greater than or equals to 0. Now, if you pass any x to this function, that is x can belong to any value between minus and infinity. Because if you pass any real number between minus infinity and infinity, then square will eventually become greater than or equals to 0. Therefore, domain of Gx will be what? Domain of Gx will be real number. So, first statement is true. What? With this, the domain of fx oh, ho, 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 ho. Again, you said S1 is the right answer. S1 is not the right answer because the range of the function is not same. So what is the range of function fx? Range of fx. If you pass any real number to this function f, then it will produce the same real number as an output. So the range of function fx will be set of all real numbers. The range of function fx will be set of all real numbers. But what will be the range of function gx? Now my question is it possible for this square root to produce the negative values? No, sir. The output of this under root of s square will always be a positive value or 0. Therefore, range of function gx will be all positive real numbers along with 0 will be all positive real numbers. It can produce all positive real numbers as well as 0, but it can never produce negative real numbers. It can never produce negative real numbers. Therefore, range of function gx will be what? So what are the values which can be taken by the function gx? So the values which can be taken by the function gx will be 0 or 0 or positive real numbers. It can never take negative real numbers as an output. It can never produce negative real numbers as an output. Therefore, range will not include those numbers. So what can we say? The range of fx is not equals to range of gx. Therefore, not identical. You need to be attentive when you are providing the answers for such type of questions, whether functions are identical or not. So you need to look at all those three aspects. What are they? The domain must be equal, range must be equal. If both of them are satisfied, then you need to check for different values of function fx and gx. Anyway, so this is it. Let's move to the next definition, that is identity function. What do you mean by identity function? Sir, identity function is defined on the same set, that is from set A to set A. What is an identity function? A function f from set A to set A is called an identity function if each element maps with itself. Each element of the domain maps with itself. So if each element of set A is mapped to itself. Now let's take the idea that if we have a set A and codomain will also be set A, because this is the function from set A to set A. Now if we have values A1, A2, A3, A4. This, let's assume that these are the 4 elements in set A. So every element needs to map with itself. So A1 will map with A1, A2 will map with A2, A3 will map with A3, and A4 will map with A4. So how do we denote this? Now, an identity function on set A identity function on set A is denoted by I on A. Identity on any set A. If you are denoting an identity function on set B, it will be I on B. Okay, so that's just the simple function, identity function. What happens? That every element of the domain will map with itself. Every element of the domain will map with itself. Next one is constant function. So what is our constant function? Let's try to understand this pictorially first, and then I will define definition. So let's assume that this is your domain. This is your codomain. There may be any number of elements. The codomain, important. There may be number of elements domain, and there may be any number of elements in the domain. Now, sir, if you look at a constant function, the graph or constant function will be like this. This is your x, your y. So, for all the values of x, the value of y should be fixed. It can be any value. The value of y should be fixed. So, it is a constant function whose value does not change as you change the value of x. Value. So, whatever the value of f of 1 should be c, f of 2 should be c, f of 3 should be 3, etc. Yeah. So, what do we mean by a constant function? So, the constant function is that if all the elements of domain are mapped with the same element of the codomain, if all the elements of the domain are mapped same element of the codomain, it may be B1, that all the elements are mapped to B1, all the elements are mapped to B2. If all the elements of domain are mapped to the same element of codomain, then it will be called a constant function. A function f from a to b is called a constant function if every element of set A, that is domain, is mapped with the same element of set B, that is codomain. Every element of domain is mapped with same element of codomain. That is, f of x should be C, fixed element. Okay. We can also define the identity function in a different way. Sir, what do we mean by identity function? So we can give the definition that every element of domain maps with itself. That is, f of x equals to x for all x belonging to domain. So, if every element x will map with itself, then it will be called identity function. Similarly, if f of x is a fixed value, if the value is not going to change as we change the value of x, then it will be called a constant function. So, f of x equals to c for all x belonging to domain. If you take any value from the domain, then the output of the function should be fixed. Output of the function fixed, it will not change. Anyway, so the graph for the constant function will look like this. Identity function, if you talk about, then identity function is something like this, that this is basically the identity function. Yes or no? Y equals to fx, that is y fx, f of x, that is y, actually x. So this is the identity function. So this is just the observation. If you know the graph for different types of function, you will be able to correlate that what will be the domain, what will be the codomain, how to handle the given question. Anyway, so we are done with that. Next topic will be composite of two functions. So function composition or composite of two. So a composite function of two functions. What happens because of function composition? So a composite function of two functions combines the given function in the given order. So it is very important that the function composition will combine the given function in the given order. That is, for given two functions f and g, the composite function may be f of g. If the order is f of g, then it will be written like this, or g of f. Okay, anyway, please remember, in general, function composition is not commutative. In general, f of g will not be equals to g of f. That is, function composition is not commutative. Okay, let's try to understand the function composition. Sir, what happens if this is my function composition of f and g, if I define it as f of g, and if I pass the value x to this function, is the composition of function f and g. If I pass this value x to this function f of g, it's actually the composition of f and g given in the order f of g. Then how exactly the value evaluated? So what happens? So this argument x will be first passed to this function gx, so it will be nothing but that this x will be first passed to this function gx, and whatever the output of gx is, whatever the output of gx is, that output will be passed as an input to function gx, be passed as an input to function gx. Similarly, if I write of f of x, what are we trying to do? We are trying to understand the concept related to domain and codomain of the function. So sir, what will it be? So if I write g of f of x, then first of all this input x will be given to the function f, and whatever is produced by this function fx will be passed as an argument to function gx. Okay sir. Okay. So let's try to understand. If we have a function f which is defined from a to a, and if we have a function g which is also defined from a to a, then what will be the domain of function f of g, and what will be the codomain of function f of g? So please, sir, first of all, whatever is being passed will be passed to function gx. So the function g must be defined. Function g must be defined on this input x which is given to the function f of g of x. So if function g itself is not defined on this input value x, then f of g cannot be defined, because first of all this value of x will be passed to function g. So whatever is the domain of the function g is, whatever is the domain of the function g is, that will become the domain of the function f of g. Now the idea is this x will be passed to function g, this g of x will be a value from the codomain of function g. This g of x will be a value, so g of x will produce an output from its codomain, right? So g of x will produce the output from the codomain of function g. So g of x will be a value from this codomain. Now this value which is produced by function g will be passed as an input, to function f. So whatever is produced by g of x, whatever is produced by g of x, for that value function f must be defined. Now the idea is g will produce a value in set a, and function f is defined on all the values of set a. Therefore function f will be defined on the value produced by function gx. Therefore function f will take the value produced by function gx, and function f will produce the output from its codomain. That means the domain of the function f of g will be same as domain of the function g, and codomain of the function f of g will be same as codomain of the function f. So if f is a function defined from a to a, and g is a function defined from a to a, then f of g will be defined from a to a. Similarly, it's not a new thing. If f is a function defined from a to a, and g is a function defined from a to a, then what will be the domain of the function g of f, and what will be the codomain of the function g of f? So the idea is that first of all the value will be passed to function f. So the value that can be passed to function g of f has to be same as the values that can be passed to function f. Therefore function g of f will be defined only for the values for which the function f is defined. So the domain of the function g of f will be exactly same as the domain the domain of the function g of f will be exactly same as the domain of the function f. Now f will produce the value fx from the codomain of function f. Now that value from the codomain of function f will be given as an input to function g. Now the idea is function g must be defined on the value produced by function f. F is producing a value from set A and g is defined on all the elements of set A. So g will be defined on the values produced by function f. So g will take that parameter produced by function f and it will be defined on that value. G will produce its result from its codomain. G will produce its result from its codomain. Therefore, g of f will be defined from A to A. Sir, it is silly to discuss that if f is a function from A to A, g is a function from A to A, then f of g will be defined from A to A. If f is a function from A to A, g is a function from A to A, then g of f will also be defined from A to A. What's new? Now, what you need to understand is that what if f is a function which is defined from g is a function defined from A to B and f is a function defined from B to A is that if f is a function defined from A to B is a function defined from B to A, then what will be the domain of the function g of f? What will be the domain of the function f of g? Sir, the only value that can be accepted by function f of g will be exactly same as the values that can be accepted by function g. Therefore, it will take the value from set A, take the value from set A, and then function g will produce the value from set B. For those values in set B, function f is defined. So f will produce the output based on the value the function f will take the values produced by function gx, and f is defined on that defined for the value produced by function gx. So f will take that value as an input and will produce the output from the set A. Produce the output from set A. So if f is a function from B to A, g is a function from A to B, then f of g will be defined from A to A. Now my question is, if this is the case of domain and codomain, how exactly the function g of f will be defined? So in g of f, the function g of f will be defined only for the values for which function f is defined. So g of f will be defined only for the elements of set B. Why? Because g of f will be defined only for the functions for which function f is defined. Now f is defined on the elements of set B. So f will take the values from set B, it will produce the output in set A. Now for those values of set A, the function g is defined. So g will be defined for the value produced by function f. So g will take the value produced by function f as an input and will produce the output from the codomain of set g. Therefore, function if the domain of the function f is from B to A and codomain of the if function f is defined from B to A, if function f is defined from B to A and g is defined from A to B, then f of g will be defined from A to A, but g of f will be defined from B to B. But g of f will be defined from B to B. Similarly, in this case, if g of f is defined, if f is a function defined from A to B and g is a function defined from B to A, then g of f. So first of all, it will take the values which are valid for function f. So it will be defined from set A. Now f will produce a value in set B. For those values of set B, function g is defined. So g will take the values produced by function f, and finally it will produce the value from the codomain of function g. That is, g of f will be defined from A to A, and similarly f of g will be defined from B to B. F of g will be defined from B to B. Sir, why this discussion? Why this discussion is still not clear? Okay, so let's assume that simple concept. But forget about two different things. One simple concept. All things work. So let f is a function from A to B and g is a function from B to C. Now my question is, what will be the domain and codomain of function g of f? What will be the domain and codomain of function g of f? Simple idea is, sir, this g of f will be defined only for the elements for which function f is defined. F is defined only for the elements of set A. Okay. Now, if you pass a value from set A to this function g of f, then that particular value from set A will be first passed to function f. F will take that value. F is defined on that value of set A. F will produce a result in set B. F will produce a result in set B. Whatever value is produced by function f in set B, the function g is defined for that value produced by function f. So g will take the input. So g will take the input which is produced by function fx, and g will be defined on the value produced by function fx. So g will take the argument from set B and will produce the result from set C. So g of f will be defined from A to C. Now my question is, which is bottom line of this whole discussion, what will happen to the function f of g? What will happen to the function f of g? Is it necessary for the function f of g to be defined? Now understand that, sir, f of g can only take the values for which function g is defined. So we will try to pass the input to this function f of g from this domain of function g, that is b. Now g of x will be a value, g of x will be a value from the codomain of function g, that is value from set C. Is a value from set C. Now my question is, function f is defined only on the elements of set A. Function f is defined only on the elements of set A. If g is producing a result in set C, if g is producing a result in set C, then is it necessary that the function f is defined for the value produced by function g? No, sir, it is not necessary. Function g may produce such values for which function f is not defined, and if it is the case, then function f of g need not be defined. Need not be defined. When exactly function g f of g will be defined? When exactly function f of g will be defined? So the idea is, note, f of g will be defined only if f of g will be defined only if, now it is necessary that the values produced by function g are such that the function f is defined for those values. That means the values taken by function g, the values taken by function g must be in the domain of function f. If g produces any such value which is not in the domain of function f, then f of g will not be defined. So for f of g to be defined, what is necessary? For f of g to be defined, the value produced by function g, that is range of g, values produced. So g will produce the values which are in the range of function g. So the values produced by function g, that is the range of function g, must be a subset of function f. If the values produced by function g are contained in the domain of set f, then f of g will be defined. That means range of g must be a subset of domain of f. Is it clear to everybody? Is it clear to everybody? I do understand that the first two cases were damn easy. That if f is a function from a to a and g is a function from a to a, then both f of g and g of f will be defined from a to a. Now, if f is a function from a to b, if f is a function from a to b, g is a function from b to a, then f of g and g of f both will be defined. F of g will be defined from b to b, g of f will be defined from a to a. Similarly, if f is a function defined from b to a and g is a function defined from a to b, then both f of g and g of f are guaranteed to be defined. F of g will be defined from a to a, g of f will be defined from b to b. But if the functions f and g are defined such that f is a function defined from a to b and g is a function defined from b to c, then g of f is guaranteed to be defined, but f of g need not be defined. F of g need not be defined because function g may produce such values for which the function f is not defined. Function g may produce such values which are not valid values for function f, and in that case function f of g will not be defined. That will only be defined when range of g is subset of domain of f. Clear? Any doubt? If you have any doubt, please let me know. Otherwise, we are done with the concept of function composition. Yeah, I can do some more things. Look at this. We know that, let's say, assume that f is any function from a to and ia is identity function on set A. Then what will be f of ia? If we perform the function composition of function f and identity function on set A, what will be the result? Sir, f of ia. Now, if you pass any value x, then obviously f of ia will be defined from a to a. F of ia will be defined from a to a because ia is a function from a to a. Therefore, f of ia as well as I of f, both of them will be defined from a to a. So, f of ia will take the value from set A. Now, first of all, this value x will be passed to function ia, and whatever value you pass to function, identity function on set A will produce the same value x. So, it will be same as f of x, that is function f. So, this is same as function f. So, f of ia function composition with identity function will be same as your original function f. So, either you say f of ia or ia of f will be the same thing. Why? Please try to understand. So, first of all, we will pass this value x to function f. Now, this function f will produce a value in set A. Now, if you pass any value from set A to identity function on set A, it will result the same value which is being passed to the identity function. So, it will produce f of x, that is f. It will produce f of x, that is f. Now, what if function f is defined differently? Let us, if let f is a function from a to b. So now my question is, what will be f of ia? What will be f of ia? Sir, f of ia will be equals to f. Let me explain. Sir, f of ia will be nothing but f of ia. If you pass any value x, then what will happen? So it will be f of ia of x. Now, whatever value from set A you pass to this function ia, it will produce the value x. So, it will be f of x, that is f. But what if I write ia of f? What if I write ia of f? If you write ia of f, what will happen? Sir, ia, now f of x. This what will happen? This what will happen if I write different? Right, ia of f of x, then we'll first pass this x to f. So this will be ia of f of x, because first this x will be passed to function f. Now the idea is this value produced by function f, the value produced by function f will be from set B, right? So value from set B, this is a value from set B. Now identity function on set A is defined. Identity function on set A is defined. Identity function on set A is defined only on the elements of set A. But function f is producing a value from set B. So function ia need not be defined. for value produced by fx. But if you think intelligently, then IB of f, IB of f will be a function defined from A to B. IB of f will be a function defined from A to B, and IB of f will be actually equals to f. So f of IA will be equals to f, but IB of f will be equals to f. IA of f need not be defined. IA of f need not be defined, and f of IB need not be defined. F of IB need not be defined. Kajal is asking difference between function and mapping. When you say function, it is guaranteed. Listen to me carefully. So when you say function, every element of the domain will map. It's also a kind of mapping, but in our function, every element of domain will map with exactly one element of the codomain. Will map with exactly one element of the codomain. In our normal mapping, one element of set A can map with any number of elements of set B. Like relation is a normal mapping, relationship is a normal mapping, but function comes with a constraint on mapping that every element of the domain can map with exactly one element of the codomain. Clear? So that's the idea. So please, I completely understand that you may be thinking that what did we learn in the today's class. So we have understood the basic concepts of function in the today's lecture. Tomorrow we will have more informative lecture related to function. We will try to understand injective function, surjective function, bijective function, how to obtain the inverse of a given function. But for that, this whatever we discussed today, that is what actually a function is. What do we mean by domain of a function? What do we mean by codomain of a function? What do we mean by range of a function? So these things are important to understand the concept of injective function, that is one function, surjective function, that is onto function, and bijective function. Then we understood the concept. Then we learned that how do we calculate the number of functions from set A to set B. Then in tomorrow's session we will try to understand that how many one functions are possible from set A to set B, how many onto functions are possible from set A to set B, what do we mean by bijective function, and when exactly the bijective functions are possible, and how many bijective functions are possible from set A to set B. Those are the type of questions that can be asked in the GATE exam. But whatever we discussed in the today's session will be core for tomorrow's session. To understand tomorrow's lecture, we must first know the basic concepts related to functions. So that's what we have discussed. We have also discussed different types of functions. What do we mean by identical function? What do we mean by identity function? What do we mean by constant function? What do we mean by composite of two functions, etc. So that's all that we have discussed in the today's session. Tomorrow we'll discuss more about functions, and tomorrow will be the last session for function. You don't need to discuss too much about the function, because very rarely a question of 1 mark will be asked from this topic of function in the GATE exam. Anyway, but still every marks count in the final result, therefore we cannot skip the topic. That will be all for this particular. Thank you very much for joining the session. See you tomorrow to understand more about functions. Thank you very much. Keep learning. Have a nice day.